Okay, so welcome back to another video. So here we are given two numbers and the question we are being asked of which between these two numbers is larger. 0.2 or 1 over 5, if you want to deal this with fraction, or tangent of pi over 16. Well, obviously it'd be easy if you were to plug this into the calculator and input these two numbers, and you'll see that 0.2 is indeed bigger than tangent of pi over 16. But suppose you weren't you were asked this question in a similar format, but you were not allowed any usage of a calculator or any sort of device. So you're stuck between a hard place trying to ask yourself, how do I proceed forward? Where do I start? Well, have no fear, because the way this method is we're going to approach is that we actually let some, we set one equal to the other and then use some sort of identities, especially because we have a tangent of pi over 16, well, a tangent function, I'll specifically say it like that. You'll be utilizing that to make the comparison of, of course, finding which number is bigger than the other. But again, it's using, your typical algebra, standard manipulation, and then really it's all about using, the identity of the tangent function and then seeing how you can proceed forward from there. So that's the premise, so why don't we actually just jump right in. Suppose we let tangent of x equals 0.2, or in other words, we write this in a fraction 1 over 5. So now we'll actually be using the double angle identity for the tangent function of tangent of 2x. We'll be using that identity such that the formula for this is equal to 2 times tangent x, and then we divide this by 1 minus tangent square of x. So we just plug in, our values in. So tangent x equals 1 over 5. So we substitute that 2 times 1 over 5, and then all this being divided by 1 subtract 1 over 5 square. Then if we actually just perform the calculation, so we have a 2 over 5 on the numerator, and then on the denominator, it's a 1 subtract. So this will be 1 over 25. Then if we just, perform, the division over here, so it's 2 over 5. Then multiply by, this will be, so 25 minus 1, so it's 24. Flip the reciprocal, so 25 over 24. Then we see that we can actually just perform the multiplication. So this is 50, and then divided by 120. Well, we can reduce that down to 5 over 12. So what does this result have to do with anything for making these comparisons? Well, we'll be actually doing doing the same format again. Instead, we'll be doing tangent of 4x, and you will see the result on after this computation to see why this is important to deal with. So if we do the same thing again, so just substitute for this, now it's just 2x for the input. So this will be 2 times tangent of 2x, then divided by 1 subtract tangent square of 2x. Then if we just make the substitutions in, so 2 times tangent of 2x, we set that's 5 divided by 12. Then on the bottom, this is 1, then subtract 5 over 12 square, performing the necessary calculations. So this will be 10 over 12 in the numerator. Then 1 subtract, this is 5 squared divided by 144. So yeah, let me put that down. 25 and then 144. Then we just perform this out. So 1 over 12, then multiply, so flip the reciprocal. So on the top, so let's see, we have, so 144 minus 25, that's 119. So this will be 144 on the top, and then 119 on the bottom. So if you actually reduce all this out, you'll get that after the reduction, this will be 1 over 20 divided by 19. But if you actually make a little bit of a comparison, obviously you'll see that this is actually strictly greater than 1 so far. Then we can say that tangent of 4x is strictly greater than 1. So we create ourselves this, little bound, this inequality, and see that we have the following. We can also write 1 as tangent of pi over 4. So that's why this is important that we actually establish this identity over here. Then by applying this, so we can actually just take the inverse arctan of both sides. So we have 4x and then strictly greater than pi over 4. Then if you were to solve for x, so multiply, or rather divide 4 to both sides, so we have x strictly greater than pi over 16, then all you have to do is just take the tangent of both sides. So we have tangent x is greater than tangent of pi over 16, but just do that substitution because we said that tangent was equal to 0.2 or 1 over 5. And so we see that 0.2 is indeed greater than tangent of pi over 16. And if you notice that tangent of pi over 16 can be numerically evaluated as 0.19. I know there's more decimal expansions, I don't remember that, but obviously that's what it comes down to. But we have actually shown this without using the without any sort of usage of any device / calculators in order to, you know, determine the two numbers in between. So there you have it. So yep, that's pretty cool if you ask me.